So this is just going to be a quick video explaining the backside of your solving note. So in these situations, we are going to end up with extraneous roots. I'm just going to launch in. Okay, so the first thing we want to do is state the restrictions. So for stating the restrictions, we take what's under the radical sign. So 2 minus m, we make it greater than or equal to 0 because we can't take the square root of a negative, as I explained in the first video and in the past. And then we solve. So there's actually a couple ways you can solve this one. There's one really easy way. I'm just going to show you right here. And this is the way I would solve for something like this probably in the future, but I'm going to show the other way in a moment just to show a point. So I would actually just add m to each side, and then that gives me 2 is greater than or equal to m, which of course, because we're interested in the perspective of m, if you're reading that left to right, yes, it's 2 is greater than or equal to m, but we're interested in the perspective of m. So from the perspective of m, this is m is less than or equal to 2. Okay, now I'm going to show this over here. So if I solve by bringing the 2 over, I'm going to get negative m greater than or equal to negative 2. Then I need to divide by negative 1 in order to get m alone. And the reason why I want to show it to you this way is to remind you what happens to an inequality symbol when you divide by a negative. So negative m divided by negative 1 is just m. Because I divided by a negative, my sign switches directions. And then negative 2 divided by negative 1 is positive 2. So again, we get that m is less than or equal to 2. All right, and that's what this is saying as well. M is less than or equal to 2. So that is my restrictions for this one, no matter how I did it. So m is less than or equal to 2. Now I want to actually go through the steps of solving it and then verifying my solution. So in this case, my radical is already isolated, so I can go straight to squaring it so that I can drop that radical line. What you do to one side, you do to the other. So on this side, m to the power of 2 is just m squared, of course. Here it drops the radical sign because they're opposites, so we're left with 2 minus m. Then I want to bring everything to one side. So yes, you could bring the m squared over. I'm actually going to choose to subtract 2 and add m so that my m squared stays positive. So add m minus 2. So on this side, we get m squared. I added m, so plus m, and I subtracted 2, so minus 2 equals 0. Then you factor. So what multiplies to give negative 2 but adds for 1? That's m plus 2 and m minus 1. Make each bracket equal to 0 and solve. Here I get m equals negative 2, and here I get m equals 1. So to verify, I plug those back in. Now, first of all, check your restriction. So both of those things are less than 2, so we're good to go there. Now I need to plug them both back in. So I'm going to start with this one, and it's because I know this one's going to work. So I'm going to plug 1 in. So I get 1 equals the square root of 2 minus 1. So 2 minus 1 is 1. Square root of 1 is 1. So we get 1 equals 1. Awesome. This works. Now, when I plug it in for negative 2, I'm actually going to have to introduce something a little new to you. So when I plug in negative 2 for m, I get negative 2 equals the square root of 2 minus negative 2. Okay, negative 2 equals 2 minus negative 2 is like 2 plus 2, so that's 4. Now, at first glance, you're going to think that's true because the square root of 4 is plus and minus 2. Now, I have to introduce a new concept. When we are working with radicals, we are interested in, when we are working on solving radicals, we are interested in what's called the principal root only. And the principal root means that we only take the positive answer. So even though this is technically correct, it is an extraneous solution because when we are solving, we only want the positive answers. We work with principal roots only. So when we're solving, the square root of 4 is actually only allowed to be positive 2. And the reason for that, I don't want to get too far into it, but the reason for that actually has to do with what you're really doing when you're solving. So when you're solving, you are looking for a point of intersection. is what you're doing. You're looking for the x value of where those two graphs meet. And that was the same for rational expressions. Remember, we talked about that really quickly. You're going to do more of this in future courses. So I'm not going to get really far into this, but what I have done is I've actually prepared this graph. So this graph would actually be, you have one graph that is y equals m or y equals x, the line. And then you have another graph that is y equals radical 2 minus m. And what you're technically looking for is you're looking for the places where those intersect. So this would mean that they're going to intersect at when m is 1, so when x is 1. And here they can't intersect at when x is negative 2. And that's why we're interested in that principal root. So just to show you really quickly, I've made these graphs already. So this graph shows what y equals radical 2 minus m is. And that's this line here. And basically the reason why we're only interested in the positive roots is because this graph is never going to exist down here in the negatives. It is always going to look something like this, or if it was a little different, oh, it's not going to let me draw on that. There we go. It also might look something like this. But either way, these radical graphs are never going to exist down here into the negatives, which is why we're only interested in the principal roots when we're solving, because we know that that graph is never going to exist down here. So we're only interested in the principal roots. So you'll see it does intersect when x is 1. And then if this graph did exist down here, you would see that it might exist when x is negative 2. It might touch again here. But because the graph doesn't exist down here, it's impossible for it to touch when x is negative 2. Okay, so I don't want to go too far into that. I just wanted to show, for those of you who like to know the why of things, why we only take the principal root. We only take the principal root because this graph is only going to exist for our positive answers, not for our negative answers. Okay. For the rest of you, if you just like to take things at face value, then when we are solving, you are only, when you take the square root of something, you are only going to take the positive answer, not the negative. Okay? That's that. All right, so looking at example B. And actually, you know what? I'm going to go to example C because this whole principal root thing is going to come up again in example C. You'll do example B on your own. So for example C, I have a negative radical 2m plus 3, positive m here. There's actually a couple ways you can simplify this. I'll do it the way that most of you would probably go to. So we'll subtract m. We'll subtract m. I forgot to state the restrictions. I'm going to do that in a minute. So on this side, you're left with negative radical 2m plus 3 is equal to 6 minus m, or negative m plus 6. And then I'm going to do something else with that in a minute, but we're supposed to state the restrictions first. Sorry, I'm bad for that. So we take what's under the radical sign, so 2m plus 3, we make it greater than or equal to 0, and then we solve. So bring the 3 to the other side. We do not change the symbol for that because all we did was subtract 3. We didn't divide by a negative. So then you divide by 2, and again, that's positive 2, so your symbol is going to stay in the same direction. So m has to be greater than or equal to negative 3 over 2. And to be perfectly honest, it's usually if your variable under the radical is positive, your restriction is going to be greater than. If your variable under the radical is negative, your restriction is going to be less than. But anyway, solve every time. Now, what I can do is I can actually divide by -1 before I square it. Now, do you have to? No, you can square afterwards. Most of the time, if the thing on this side is divisible by whatever's attached, you're going to want to do that first. It just makes the next steps slightly easier. In this case, not a big difference, but for future examples, you'll see if there's something attached and the other side is divisible, usually a bit faster if you divide first. So we'll divide by -1. All it does is eliminate the negative in front here, and this side it will change all of the signs. So the negative cancels out. We are left with radical 2m plus 3. And then on this side, negative m divided by -1 is positive m. On this side, positive 6 divided by -1 is negative 6. Now our radical is isolated, so we can square each side. Squaring the radical just drops the radical sign, right? They cancel each other out. M minus 6 squared is not m squared plus 36. You would have to FOIL it. So it's m minus 6 times m minus 6. All right, so that's actually going to be m squared minus 12m plus 36. Okay, and I shouldn't have to go over foiling with you. So I know that that's the answer. If you need to FOIL that out to get that, go for it. Then I'm going to bring it to one side. So this side is now 0. Then we have m squared minus 14m plus 33. What multiplies for 33 but adds for negative 14? And that's going to be m minus 11 and m minus 3. Okay, so that gives me m equals 11 and m equals 3. And then I would verify for both. So I am going to start with the 3 because that's going to show my principal root thing again. So if I plug it in to the original, remember, so 3 minus, oh, sorry, I wrote m again. I'll change that to a 3 in a second. 2 times 3 plus 3 is equal to 6. This should have been a 3. Okay, so that's 3 minus 2 times 3 is 6. 6 plus 3 is 9. If I am only taking the principal roots, this has to mean 3 minus positive 3. Okay? And 3 minus 3 is obviously 0. Kind of looks like a 6 for a second. So 0. And 0 is not equal to 6, meaning this is extraneous. If you didn't take the principal root and you did 3 minus negative 3, that would be like 3 plus 3, which is 6, and you would get 6 equals 6. Technically, that's correct, but because we are solving for points of intersection, we are only interested in the principal root because that's the only part of the graph that will exist. Okay, so this, we are only interested in positive 3, not negative 3 answer, because we are working with principal roots only when we are solving. Okay, so the square root of 9 can only be positive 3, and 3 minus 3 is 0, so this is extraneous. All right, now when I plug in 11 minus radical 2 times 11 plus 3 should equal 6. 2 times 11 is 22. 22 plus 3 is 25. Square root of 25 is 5. And 11 minus 5 is 6. So we get 6 equals 6. Yay. And again, when you take that square root of 25, we're only interested in positive 5. Okay? So that's it. That one's your solution. That one is extraneous. Okay, so you are going to try example B on your own. It's going to be very, very similar to C. So you'll try that one on your own, and the answers are all in class notebook on Teams. Okay, hope that makes sense.